Hello and welcome to the Raspberry Pi coding channel. This is the third video in my Humans versus AI video series, where we're going to create a basic game and have a reinforcement learning based AI agent learn that game and eventually compete against humans in an online battle it out kind of environment. But for now, we're just trying to create an environment in which we can render the basic game logic and then train the reinforcement learning agent to play it. So we're kind of starting quite simple. In the last video, we did create the game window and we created the game grid on which we're going to put things that the agent will interact with. But we found already we were getting some issues around performance. Now, it's important not to optimize early, but at the same time, it's important not to do daft things and make the rendering loop slow, which is what we were doing. So we're going to change the logic in how we're rendering the background, the grid, so that it no longer is so computationally inefficient in this video. It's not a difficult thing to do, so I'm going to go through it quite quickly and should be well within the 15-minute window I give myself for these videos. Quick comment, if you're already a patron of mine, thank you very much. And remember that you can access the code seen in the videos if you want to copy and paste it from there. You also have early access because I release videos every few days ahead. So there should be quite a few videos, for a while at least, that you can access early. Okay. Moving on then back to my IDE, and we'll go through today's content. So in the previous video, without going into the detail of it, we were using Arcade and we created a game app class and tapped into two important methods, onUpdate and onDraw. These methods are run as part of the game loop, so they run with every frame. With onUpdate running just before onDraw, and we're drawing the frames per second, which uses Arcade's draw text method, and we're rendering a grid by drawing the rectangles within the onDraw loop across the window and up the window to get the full grid on the screen. And it's this which is the problem, which we're going to solve today. Okay, so let's get cracking onto this file. The first thing we're going to do is going to import Pillow. Now, a bit of fun information, Pillow actually is under the hood in Arcade already, so we could use the Pillow library without doing this, but it's bad form to do so. So if we go to our, and this is one of those Blue Peter moments, if we go to our window here, terminal, sorry, I've done it already for the sake of time. Make sure you're in your virtual environment. Type in pipenv install Pillow if you're using pipenv for your environment, and it will install Pillow as a dependency explicitly, so that we've got that. And now if we do cat pip file, we'll find that not only do we now have Arcade, we also have Pillow. Okay, so going back to my IDE. Right, so there's the import, so that's the first change. Now if we scroll down, we've got some more. Firstly, we've got a new function called setup, which is not a Arcade function. That's one of mine. I've created that. Setup function is very useful. It'll include all the logic we need to run before the game actually starts. It's a very useful thing to have. I've just put print setup in here for now, just to show it's working. And then if I scroll down a bit more, we'll see where it's actually run. We're running it just before we kick off Arcade, which is our game loop. So it's just before the game loop. It's when we want to set up the game. So it makes a lot of sense. Otherwise, everything is the same. So just to make sure it's running properly, if I run this, we should see the grid appear. We should see the frame rate being quite rubbish, which it is. And we should see down here, setup has been run. So we know it's working as it should. Right, moving on to the second then part. The next thing I've done is I've split out grid size into X and Y components because it seems unnecessarily restrictive to have it square all the time. So it's now able to be rectangular. I've adjusted the screen width and the screen height to reflect the dimensions of the grid. And I also have now reduced the tile size to 12 pixels, excuse me, so that we can have more grid tiles to prove that we solve the problem of the inefficient rendering. So with that done then, with the dimensions set, the next thing that's been done is we've created a grid texture object within the game app class, which is currently set to none, just so we've got scope and it's initialized. And then in the setup function, we've now no longer got a placeholder print statement, but instead we're calling a function we're going to create in a few minutes called create grid texture, which is going to create the grid texture arcade texture object. This will be an arcade texture object that we can use within our rendering loop. So that's the next thing that's done. Setup is now being used to call a function. Then if we have a quick look, we've replaced the code that was causing us so many problems before with a to-do statement, which is where we're going to put in our new texture rendering code when that's done. So we've lost the loop, which had the rectangles being drawn in a nested row and column loop. And then finally, we've got the function that we're going to populate, which at the moment just has a print statement to tell us it's working properly. So I'll run this and we should see create baked grid appear, and we should see no grid. So the grid is gone because we've removed that inefficient code. And in the terminal, we can see create baked grid. Okay, good. So we know what we're doing. We're running a setup function just before the game loop starts to create the texture, to bake it in. We just need to now write the code to actually do that. And that's what we're going to cover in the next section. Right, so here we go. We'll come back to this. That's the drawing code. We'll come back to that in just a second. But the function, the method that I've just mentioned we were going to create is just here. So it's not that complicated. It is basically making use of Pillow's capabilities. So first off, we create an image object in Pillow using the image method. Excuse me. Actually, the image class, apologies. We'll be creating an instance of an image class and calling it image. And we're using a kind of a dimension of the raster of screen width and screen height because it should fill the entire window. So we're using these constants. And we're giving it a black background. If we wanted to give it a white background, this is where we'd have to change it. So because rasters have to have all of the pixels between the lines filled, whereas of course with vectors you don't, we have to make sure we set what we wish the background to look like. Currently I've got a black background, so that's why I've set it as a black background here. We then create a draw object out of the image object so that we can edit it. This is required in Pillow for us to actually draw on top of that image object. So we do that, and then we do draw on it. This is pretty much the same as what we had before. We iterate over the rows and the columns using grid Y and grid X, size X constants, defining the corners of the rectangles, X0, Y0, X1, Y1, and then we draw the rectangles. The only thing that's different is we're defining our own version of dim grey, which if you remember was what Arcade referred to for the colour I'd chosen. It was called dim grey. We've just defined it here as 105, 105, 105, 255. So that's how we draw onto our image object, and then we just need to create a arcade texture object from that, and we do that here using the Pillow image as a reference. So we've had to write nothing to file. There's no I/O onto the hard drive. We've done all of this in memory, and we've baked it into the texture object, which we then return. And of course, if we go back up here to the setup function, we can now see it all makes sense. We're returning the grid texture, and we're populating the object the variable that we created above. So the last piece of the puzzle then, having explained what create grid texture does using Pillow, is to actually render it. And this is now the rendering code. This is much more efficient. We're just using the Arcade's draw texture rectangle method, which defines the center point of the texture and its dimensions, which in our case we know is the screen width and screen height because that's what we used to generate the texture. And then you pass it the actual texture object, which we've obtained in the setup. So that's great. We've got a programmatically generated texture, which is important because if we wish to change the dimensions or randomize the size, for example, as part of game setup, we can do so. This isn't being baked into a file. It's entirely programmatically done. And that brings us to an end of this video. I'll just expand the rest of it. In the next video, so what we're missing, actually I have not proven it, I press play here and I will show, here we go, yes, there we go, apologies, the all-important reveal, 60 frames per second and a much finer grid. And what's happening here is what's in the background is actually not a vector anymore, it's not loads of vectors, it's a rendered texture at the resolution of the window. So unless you were physically to zoom in, you would not be able to tell, and it's really efficient. So what we're missing then, which is where I was going to go just a moment ago, is we need now to populate this with players and the notion of a game state so that we can have a player's location and they have the ability to move around the grid, and there'll be more than one player. And then eventually we'll populate the grid with things like energy to collect, things like that. So this is good progress. We now have a grid that is rectangular, doesn't have to be square, programmatically generated and efficiently rendered. So in the next video, let's add some players to it. Thank you for watching. I hope you found it useful, and I hope to see you in video 4. Thank you.